All right, FEP Hydraulics Homework Problem 8 from Chapter 4. This time we've got a box culvert that we want to install at a new location, and we have the stream information from the problem that came before. And we're going to improve the channel so that we have a depth set to 4 feet. So now we're going to have a set depth, but we're going to have to figure out what the width will be. So the improved channel section must have the same side slopes and grade as the natural channel, but will be lined with Class 1 riprap. So we were given information before that that side slope was 3 to 1, so m equals 3. And now we know that that y is going to have to equal to 4 feet, because that's going to stay the same. And we also know that we're going to have a riprap lining coming on here. So we're going to have to find out that Manning's n by taking that diameter of the stone, which is 10 inches, raising that to the 1/6 power, and dividing that by 44.4, which gives us a Manning's n of 0.033. We're also told in the last problem that we had a slope of 0.9%, so I'll write that as a decimal, 0.009. All right, so now we're going to use the depth limited procedure, very similar to the normal depth procedure, except for now y is always going to be 4 and b is going to vary. So we'll start off with b equals 10 feet. We're told to do that in the problem, so we'll start with 10 here. And then we know y is always going to be 4. So this equation becomes 4b plus, and then we can take a look here. M is 3, y is 4, so 16 times 3 becomes 48, 4b plus 48. And for wetted perimeter, we have again b, which is going to vary, plus, and then now we know that y is 4, so we have 8 times the square root of 10. I'm just going to write that as a decimal, 25.3. All right, so let's plug some values in here. If b is 10 and y is 4, that area becomes 88 square feet. The wetted perimeter becomes 35.3. The hydraulic radius becomes 2.49. And my z average is 161.8. So we want to check that with our z required. Remember, our z required here is the q times n divided by a 1.486 conversion factor times the square root of s as our decimal there. So let's plug the numbers in here. For the z required, our flow rate is the same as it was in the last problem, so it is that 800 cubic feet per second. And then we just found that new n, 0.033. And then we'll divide that by the 1.486 and the 0.009. So that makes my z required wind up to be 187.3. So we're going to compare all of the different answers that we get to that 187.3 value. So first we got 161.8, that is less than the 187.3. So that that 10-foot width is it's not wide enough. Okay, it's too narrow. So we're going to have to go a little wider here. So we'll go to 11 feet width now. Using 11-foot width, we get 92 square feet for an area, 36.3 feet for that wetted perimeter, 2.53 hydraulic radius, 171. Now for a z average, still 171, still smaller than that 187.3, so we're still a little narrow there. So let's go ahead and increase that to 12 feet wide at a base. That gives us 96 square feet for the area, 37.3 feet for wetted perimeter, 2.57 for the hydraulic radius, 180.3. Oh, still too narrow. Okay, 180.3, still less than that 187.3, so still too narrow. Let's go ahead and increase that one more foot here by up to 13 now, which gives me an area of 100 square feet, wetted perimeter of 38.3, and you can see the pattern here. Every time I increase by a foot, it's increasing that wetted perimeter by 1 foot. 2.61 for hydraulic radius, 189.6. Okay, now I'm getting a little bit too big. So 189.6 is now greater than that 187.3, so a little too wide now. So let's bring that in just a little bit, see if we can get a little closer here. I'm going to use 12.8. And with 12.8 and always the 4 for the depth, limited depth procedure. So now I get a 99.2 for my area. Now I'm kind of in between here, so I'm down to 38.1. 2.60, so very close to what I had before, but just a little different. And look at that, 187.75. So that is super close, and we will call that the winner. Okay, 187.75 versus 187.3. And then just finishing up the problem, it does ask us to find the minimum base width. And so we've got that minimum base width here is going to be the 12.8 feet. And we can also go ahead and solve for that velocity too. As we know that velocity is going to be our Q over our A, in this case 100 cubic feet per second divided by the area here of the 12.8 foot base width, 99.2 square feet, which gives me a final velocity of 8.1 feet per second for problem 8.